We go. Today we're going to talk about chemical bonding, and I'm going to talk about um, four types of chemical bonds. Four types, and those are going to be, we're going to talk about ionic bonds. We're going to talk about covalent bonds. We're going to break those into four different groups. We're going to talk about what else? We're going to talk about hydrogen bonds. And we're going to talk about the van der Waals forces as well. So we're going to break our chemical bonds in this class up into four different groups. The first is ionic bonds. And if you remember, talking about atoms, remember that there are electrons which are on the outside of the atom, and on the inside of the atom, right here, there are protons and neutrons. And essentially what happens is you can attract, depending on how many protons you have, you can attract a certain number of electrons. So in this case of sodium, represented by the Na you see here, you can attract 2 electrons in the first energy level or energy shell. And then we have number 3, 4, 5, 6, 7, 8, 9, 10 on the outside of this particular one. Actually, and then number 11 right here. So what happens is the atom is balanced in an electrical sense in this way when it has the same number of protons as electrons. But because these electrons are spinning around this atom, there's also a balance that goes on based on having the outermost shell of electrons filled with electrons or having it empty, so that the inner layer is filled with electrons. So what happens is every now and then, like in the case of sodium, one of these electrons here gets sort of ripped off or moves to another atom. So in this case, when sodium atoms are near chlorine atoms, what happens is chlorine, with its 17 electrons, is in a state of being able to gain an extra electron here so that it fills up its outermost shell here. And sodium, by losing this one, ends up filling this outermost shell. And they'll form what's called an ionic bond, where you have a sodium atom here, and you have a chloride ion here, and this one's a +1 charge because now it has more protons, one more proton than it does electrons. This now, the chloride, has one more electron than it does protons. Hope I said that right. This one ends up having 11 protons, 10 electrons, so it's a positive charge. This one has now 18 electrons, 17 protons, so it's a negative charge. And so the positive charge is attracted to the negative charge. The other thing that can happen is atoms will get together and they'll share electrons, so that the electrons spin at some point around both of the atoms, and that's represented by this line that you see here. Whoops, let me go back to that. That line represented that you see there, that's, did it again, sorry about that. User control issue, trying to learn how to use these pins and all these devices at once. There is the covalent bond that you see there, representing that line, showing that you're sharing 2 electrons, as you see right there, between the 2 hydrogens. And we'll divide the covalent bonds into 2 types: polar covalent bonds and nonpolar. What happens in a polar covalent bond is the electrons are shared unevenly. I'll show you that in a second with water. In a nonpolar covalent bond, the electrons are shared equally between the 2 atoms, so none of the hydrogens here pull the electron more than each other, resulting in a nonpolar covalent bond. Going back to the polar covalent bond here, what ends up happening in this case, if you have water, which I'm sure you're very familiar with, the water, I did it again, sorry about that, the water molecule H2O, what ends up happening, you have 2 hydrogen ions here. This is number 1, and this can be number 2, and then this is the oxygen. What happens is the oxygen is more what we call electronegative. So it pulls the electrons more. So what happens is, even though these two hydrogens are sharing electrons, the electrons are pulled more towards the oxygen. And as it does that, the oxygen side of the atom becomes slightly negative, and the hydrogen side becomes slightly positive. That's a polar covalent bond. So there's the bond right there. There's another bond right there. And what ends up happening is when you take water and the water is mixed with other water molecules, what ends up happening is this bond right here becomes your hydrogen bond. So the bond between the oxygen here and the hydrogen here, that's your polar covalent bond. That's your polar covalent bond. And this bond here, which is a very weak bond between the positive, slightly positive and slightly negative oxygen on one and hydrogen on another, that is your hydrogen bond right there. Hydrogen. There's an O in there. Okay? So that's your hydrogen bond. Now, what happens is there are cases, and this is our fourth type of bond, where even if the electrons are shared equally, like in this case here, what you have is you have these rings. And so anytime they draw these rings like this, if they don't tell you otherwise, at the corner of each ring is a carbon atom. Carbon tends to share equally among other carbon atoms. But what happens is, as the electrons spin around, there's moments or times when the electrons are slightly unbalanced, resulting in slightly negative and positive charges. At those times, those are called the van der Waal bonds. Even two, say, carbon atoms in a molecule could be very weakly attracted to each other because of these weak bonds. And again, those are the, in this case, in our class, the fourth type of bonds, the van der Waal bonds.